Hello, everyone. I'm David. Well, last time I was here, it was roughly 9 years ago, so it's good to be back at home. Probably nobody knows me here, since I was only here at my university time. So mostly I've been working on NLP and data engineering back 4 or 5 years ago. And I'm a contributor to a project called Wikipedia, which has to do to information extraction and NLP. I've been a Google Summer of Code for the last 2 or 3 years, so just look it up. And if you are interested in a Google Summer of Code, just give me a poke. I also been working on open data in Colombia, mostly remotely. So I've been open source, like opening some government spending data sets and talking about how to access data sets. Recently, not so much interested in this, but please, if you're really interested in open data, give me a poke. We would really like to discuss about it. I'm also really active on Colombia Dev, so feel free to go to that Slack and say hi to me. Recently, I've been working in ops, mostly Python and Golang, for a Japanese company called HDE, which actually turns out to be one of the sponsors of PyCon. And please come to our booth because we are based in Tokyo and we offer an internship where basically we fly you to Tokyo and make you work on really cool projects. And we are looking for software engineers. We have cool problems to solve. So check our booth. Go back to my talk and let me give you a little bit of context. So roughly 1.5 years ago, I joined HDE. So as my first week, I started looking at projects. So I just go through GitHub repos and start looking what's going on. And I also had a new project to work on. So turns out that some projects, actually many of them, were built on top of serverless. Something I've actually heard before, but was not very familiar with. So in this talk, I would guide you through some of the tools, some of the use cases, and some of the common mistakes that I saw people making, or even myself. And I'll also give you my opinion about this technology and tools. My first task in this company was to do log stream processing. So what is log stream processing is basically you have a bunch of data coming in a stream, and you have something that transforms that data and creates analytics and metrics in near real time. So if you have been doing data pipelines, kind of data science or data engineering, you probably try to build that in Apache Storm or in Apache Spark. The problem with those things is that there's a lot to configure, a lot to manage. So there is Zookeeper, there's a yarn cluster, there's a driver instance, there are the JVM configuration, and there is HDFS, which is a monster out of itself to set up. So basically, at the end of the day, you feel like this, like I felt in my previous company for running that HDFS and Zookeeper. So you have to make sure all those parts are running as smoothly. Otherwise, you're just going to fall on them. And then I met Jeff. Well, maybe not that Jeff, but a coworker who is an ops engineer. And he loves serverless. I think he's the main cause many of our projects are on serverless. And he has good reasons for it. Well, he does not want to do any server management on the first place. So Jeff suggested to use serverless to solve our stream processing problem. And I raised my eyebrow in doubt. What? Serverless? A quite controversial and confusing term. Serverless basically means many things, but mostly it means two things. Fully managed services that are managed on your behalf. Basically, another company is running that for you and making sure it's always running. These are databases like DynamoDB, or storage services like S3, or queues like Kafka as a service. There are many companies doing that out there, or maybe even services like Heroku. There is another way to define serverless, which is function as a service. And this is what most people have been talking about the last year. So sample of these are AWS Lambda, Azure Function, Kubeless, Nucleo, and many, many others that have been born in the last 6 months at the time I was preparing for this talk. So what is function as a service? It's basically you upload your code and it will run. You don't care on top of what is running, more or less. you only focus on your business logic. At least that's how they sell it to you. The main point is that you have zero administration to do, so you only focus on a single function, which is managed mostly by your provider, and you gain a peace of mind because they tell you, oh, just run this on my function as a service, and it will always be running, and I can't scale it up. So you gain some peace of mind. Okay, this will always be running. I don't need to update that for security, updates of operating system, or those kind of things. So what is the cost of that is more integration with your vendor. So you are getting into vendor lock-in, basically. The second thing that are the main feature of this is that you are billed by number of invocations. So you are billed basically how many times does your function get called is basically how much you get charged. So how does this look in Python? Well, basically it looks like this. It's a function which receives 2 parameters and do something inside. You can do basically anything inside. You can scrape a URL, or you can just receive a username and do a query in a database to return the data of that user. So the main point then is like, how do you deploy these functions? I think that's the main point, because this is the point of friction for us to start using this kind of technology. So in order to run your project on this kind of technology, you need to go through these steps here, define your function, package your function, upload your package, and call your function. And there are tools that addresses all of these 4 steps. So the first step is define your function, and I call that infrastructure glue. So remember that tape icon that is there, because I called that glue. So what does that mean? You tell it the runtime. Is this going to be Python, Golang, or JavaScript? How much memory is it going to use? And what access does it have to resources? So like kind of permissions. And you can do this by mouse and clicking, going to your cloud provider website, or you can use automated tools like Terraform or CloudFormation to do this. Just remember that this is glue. The second part is packaging your function. It's simply you get your function code and all its dependencies, and then you just simply make it a zip, and that's it. Uploading a package, like it's kind of deploying it. And that's all to it. You just upload that package that you created before, and that would be the equivalent of doing a deployment. Calling your function, like it's call of what triggers it. This function is going to be called whenever a URL gets hit, maybe, a domain of yours gets hit, or an object is uploaded to S3, or a new record is added to your database, or maybe that function should be called whenever a queue is not empty. So this is deeply entangled on your cloud provider services. So this is also more infrastructure glue. And you can do this again by going to your website of your cloud provider and mouse clicking there, or you can use one of the automation tools like Terraform or CloudForm. So tooling actually addresses those steps, either all of them or a few of them. So deploying is basically deploying infrastructure and code. So people don't really realize this, which can be a little bit challenging. So back to my story, I started my first week looking at repos, and one of them is an API. So basically it's just a bunch of endpoints, something.com/endpoint A, endpoint B, and endpoint C. And my team was an early adopter of this technology. So they teach all of the tools that they had available at that time to make this project. And it looks a little bit like this back then. So they had a request to URL A, which will trigger a call to a function, which could be function A, and then they made the same for the other endpoints. So they have another trigger for URL B that would trigger function B, and they would have another trigger for function C that would trigger the function C. So they have a function, and they have a trigger for each of their endpoints. So, and to deploy, they had makefiles, which are not the most friendly of all. And to glue everything, they had Terraform. So every trigger was created on Terraform. So the problem is they had 3 functions to deploy for this project, 3 functions to package, and a lot of glue. And the problem with the glue is that these are pieces that you have to move, worry about, and especially they are extremely hard to test. So, and on top of that, changing this kind of trigger that when you hit a URL, a function gets hit, gets called, then that's really painful on Terraform. It's incredibly painful. It requires a lot of code and a lot of glue. So on top of that, running Terraform is scary. So you might destroy other infrastructure where you are trying to make a little change to this project. So if for whatever reason you want to move to a non-serverless, it's much harder. Like if you want to move to containers because you want a better performance or whatever reason, it's just harder. Why? Because all that glue that triggers the functions, you have to implement that and in a different way. And well, I just mentioned that you had 3 different lambdas, and also when you have 3 different lambdas, people, I've seen a lot of new people structuring their projects as 3 independent projects. Like their imports are awful. Like they're just very independent projects out of themselves. So with tools available today, you can avoid this. And I want to very briefly guide you to some of the ones that I used. So the first thing that we tried to change of this project was instead of having 3 gluing parts, or many depending on the number of endpoints that you want, is to make a single trigger. So whenever anything is requested to something.com, it will trigger our Lambda function. And in there will be a WSGI wrapper, something like a Flask application that would handle the routing for us. So what is a WSGI wrapper? It basically translates a wrapping request to your handler into WSGI request. That means that you can use any tools you like, Flask, Django, or whatever that uses WSGI. So you can use all the tools already available and all that come with them. That means that testing is easier. You can use the tools you have used all the time to test. You can make your API with the same tools, and let's say have serverless for free. So I was kind of happy about this. So the minimal implementation of that wrapper for Python 3 is available at this repo. So it's just a wrapper that takes whatever is coming, arriving to your function, and translating it into a way that WSGI can understand it, like a regular request. So if you have a dummy Flask app that looks like this, you just import Flask, have an app Flask, and a single endpoint, it might probably look a little bit like this, right? So actually, to make it serverless, you would only need to add a single function to this, which is have your handler function and wrap it in the AWSGI wrapper. And this app that you built before now suddenly became serverless. So this is your regular Flask application, for example. And these 2 other parameters there are the regular parameters that are passed to Lambda functions. So the cool thing about this is that now you can run your Lambda functions locally, kind of. You can run the same logic. It's very easy to test the routing because it's not glue code on Terraform. It's not infrastructure. It's the regular thing that you can test on by a PyTest or whatever testing framework that you like to use. And the thing that I like the most is that there is less glue, less infrastructure to deal with. So if you are building APIs and you're thinking of using serverless, these are some of the tools that you might be considering to use. There are way many more, and every day that I looked on GitHub, there's just a brand new tool out there. But out of those ones, I just selected these 3 ones, Serverless, Chalice, and Zappa. There are way many more, and I'm not gonna explain many details about them, but I'm just gonna briefly tell you when to use each of those. So the first one is Serverless. Because the name was not already confusing at all, they just picked this name again. And if you go to serverless.com, you will see all the information about this tool. And the good things about this tool is that it got funding. And that means that it has a lot of support, a lot of plugins. And it's, in my opinion, really good when you are trying to build something as the use case that I showed at the beginning. You are trying to build an API. For some reason, I felt it's not as sluggish for this use case. You can update endpoints really quickly. And one of the things that I like is that it provides you an easy way to handle environments, so you can very easily define each of your environments by the plugins that they already provide. And the community is really good. The bad part is that whenever you deploy using serverless, you are not only changing code, deploying code, but you are changing infrastructure. And that's something that I really hate, because when I do the command that deploys the Lambda functions, I might be unintentionally, like without wanting, I might be changing infrastructure. That means I might be destroying something. I might be destroying a database, or I might be destroying, leaking infrastructure behind. So it does not tell me what will change before deploying, and I really would love to have that in order to be able to see if I'm leaking infrastructure behind. So when I change something in the config file, I can easily leak infrastructure. It is dangerous to leave infrastructure leaking behind. That means I will leave an endpoint open, or that I will leave a Lambda function that is not updated later on. So how to use serverless? You define all your glue in a YAML file, and then you do SLS deploy. That's all that it is to it. In the YAML file, you define, I want a function with this memory, I want a function with this name, and I want it to get called when X and Y happens. And then you do SLS deploy. It's gonna it's gonna build a package for you, and it's gonna upload it. If you are using Python, and if you have a Python project in it, like a requirements.txt, it will automatically get all the dependencies and pull them down for you. So this serverless framework comes with a lot of plugins that you can add to your YAML file. Don't use it to manage infrastructure. It's really easy to get carried around and use it to define a lot of things. But don't. Just stick to your Lambda functions and to the triggers. My opinion is you shouldn't be doing this to handle infrastructure. It's really dangerous. So serverless also have something called serverless application, which is everything all together: code, glue, and infrastructure. So for example, you can have a serverless service that gets you a Slack bot that does something in particular. For example, talking to another API. Someone could have already built a Slack bot that talks to GitHub, and you just have to do serverless install, pass the URL of the repo, and then do SLS deploy to build a Lambda function, an endpoint that will already handle all the bot logic for you. So you can package all code and logic in a serverless application, which I think is really cool. There's this other project called Chalice. I think it's the first tool that I saw out there. It's made by the AWS team. The bad thing about this is that it's purely focused on AWS, so you are gonna get locked on AWS. With the other tools, you can switch across cloud providers. And in my opinion, it's aimed at the API use case. So if you have a different use case for serverless, for using this function as a service, then this might not be the best tool to use. It also comes with the WSGI wrapper by default. So you can just use it out of the box without anything else. The other one is Zappa. It's similar to serverless in my opinion. You define a glue infrastructure in a JSON file. And then some of the glue code is defined as Python decorators. So you have a bunch of fancy decorators that do things. For example, you have a task decorator that will, in principle, create a Lambda function that is independent, and it will run asynchronously when you call it. So it has really a lot of different decorators that do a lot of fancy things. I think it lacks a lot of plugins, and it doesn't adapt very well to some use cases that I'm particularly interested in. So good if you are building APIs, and if you have a lot of kind of cron jobs that should be run every day at 5 p.m. or once every week, or that are asynchronous calls, like you just want them to happen in the background. I think it's kind of difficult to test on Zappa. So I'm not very fan of this. Out of these three ones, I think I prefer serverless. However, there are some other use cases. So suppose you have a lot of data that you want to process in batch. So for example, you have a lot of text or a lot of numbers. And if you have a lot of numbers, maybe you want to count frequencies. Or if you have a lot of text, maybe you want to clean the text before doing NLP, like some sort of data preprocessing in ETL manner. So you might think of doing a map reduce, right? Because that's what people do when they have this kind of problem. So you get a Spark cluster and use PySpark on it, and then you are done. But then, as I mentioned, that's really hard. It's really hard to manage that Spark cluster. So this is a great use case for function as a service. You can have this tool called Pyrin. And Pyrin has a lot of benchmark. It's basically aimed at this particular use case, but they say they can consume up to 80 gigabytes a second and can output up to 60 gigabytes a second, which is a lot. And what they say is like, basically you don't need to know much about AWS. You don't need a large, expensive cluster running. And you can just use vanilla Python. Like whatever simple Python you already know is enough to use Pyrin. So how to set it up? You just run pyron setup. It's gonna ask you a few questions which are really easy. And what Pyrin does is essentially takes a Python function and then creates a function as a service, creates a Lambda function, takes the data that you wanna run it on and uploads it to S3. And then runs your Python function in parallel on the data uploaded to S3. So if you have a function like this one, you input a number and it returns you the number plus 1, and your data is the numbers from 0 to 9. Or if you have a function that cleans text and the input is the text and it outputs the clean text, and your data might be the Wikipedia dump, which is 100 gigabytes. Then what Pyrin does is takes that function that you want to run in parallel, creates a Lambda function, takes your data and split it and uploads it to S3 in multiple parts. And then what's going to do is it's going to run that function on those parts of the data. So for this example, it's going to run one Lambda function on the input 0, another Lambda function with the input 1, and so on and so forth. And then the output will be on S3. And then your Python program will constantly be blocking until the results are available on S3. So how does it look like? Well, it's very simple. You only import Pyrin. You generate the data. In this case, it's a list of numbers. So MP arrange 10. And this is the Pyrin magic. So basically, it's like a map function. So it takes another function, in this case, add1, and the data that you want to run it on. And then if you want to get the results, you can simply loop over the futures, and this is going to block until the S3 results are available. And by the way, this is meant to be run locally, and the Lambda function is going to be built when your program gets run. So this is very good for ETL tasks, things like scraping or data crunching in general. And so this is, I would strongly recommend this. It's really, really cool to use for data science or data engineering. There is a similar project called PyCon Colombia. So this is a crazy company which is called Qbol, and they experimented a little bit, and they just changed Spark executors to be Lambda functions. So if you are familiar to Spark, maybe this would make sense to you. And they run an experiment which is scanning 1 terabyte of data. So they have a bunch of text and they just wanted to count how many lines of text are there. And they made 1,000 Lambda executors. It took 47 seconds and the cost was $1.20. On a regular Spark, you would need to achieve this roughly 50 R3x large instances. And just to provide those instances with Spark and waiting for the cluster to know which nodes are available and so on and so forth, then that would take at least 2 or 3 minutes to get that ready, which is more money than $1.20. There are some remarks that I want to make. That means things you have to be careful when you are using this function as a service. For most of the providers, multiprocessing module is not available. So doing a map in multiprocessing is not a thing that you can do. There are some common mistakes that I've seen people do. And that is they structure their projects different, but they should really structure their projects as any other Python project. Don't think that is a function as a service, in my opinion. And if your project has many function as a service, you should think of it as a single project with different entry points. The other part that I want to warn you about is immutability. This service is built on top of containers, but this is usually hidden for you. Some containers to run the same function sometimes get reused. For example, if this is your whole project, you make a database connection and then the handler of your function just makes a query to that data to a database using that database connection, then the first time you ever run this function might look like this. This line gets run, and then the handler gets called, and your query is returned. However, the second time you run this, the first line is not going to get run. Only the second line will get run. That means that the database connection was some sort of cache there for you. And it's good in this use case. It means it was ready for you to use. But it also means that you have to be careful. As in any other project, mutable globals are not desirable. So suppose this, you have a list of users and you have a handler, and for some reason you mutate that list in that handler. And I've seen people doing this. We run into this. What is going to happen is, the first time you ever run this function, well, you're going to get the expected output out of it. That list will have the value of admin and user 1. But the second time you run it, because you mutated that list, there is the possibility that you will reuse the same container. And as a result, the actual input to that function will be the previous call and the new input data for the actual call that was made to this function. So be careful with this. Don't mutate in general is a good idea. The other thing is security. Well, dependencies, please update them. This is the most important thing to do here. Delete all functions. You might think that's really easy, but because you don't pay for them, if you don't use them, you don't get them on your bill, and then you don't get reminded. So if you don't use them, please delete them. It's very hard because you got no idea who might be the owner of a Lambda function, and you got no idea if it is safe to delete. Another thing is to straight up your permissions, only needed permissions. This is simple. And remember, denial of service attacks might be wallet attacks now. Like, yeah, you just get the cloud provider to scale you up, and then you're just gonna get charged more. So to sum it up, there's a lot of new tools coming up every day, and there are yet more to come. So serverless provides you with a peace of mind. It'll always be running, it won't be down, but you agree on going full on using your cloud provider features. There is a lot of glue, lots of events here and there. So serverless, in my opinion, is cheaper, but it's definitely not simpler. Data crunching, go for it. Handling small events, go for it. But the total complexity of your system will grow for sure. Because you will start with a single Lambda function, but it will grow into a Lambda function calling another Lambda function that gets pulled data into a queue, and then another Lambda is consuming from that queue, and then that generates another event, and it gets extremely complex. So this is your complexity, the glue, the wiring that you need to stitch all of that system together. And it might end up maybe a little bit like this. So the thing is, glue is really hard to test. This is the hard part. Testing the integration test. Does the event triggers the expected behavior that I want? You cannot do it like you do in simple Python projects, because this would be maybe Terraform. This is something that your cloud provider is doing for you. But anyway, this is the cool kids now, and it's getting more popular. According to, when I was making these slides, I checked some surveys, and it seems that the adoption of this is as fast as that of containers, which I was really surprised. I never thought that that would be the case. So I guess the new tools will help tame this complexity, that glue code that I show you. So I guess now you're wondering, should I use serverless or not? So I would say, if you find yourself in any of these situations, you have a developer who is complaining about not getting something done because getting infrastructure created is really difficult. Or maybe you're a data scientist annoyed by how difficult it is to run your experiment. Then maybe you should try it, but you shouldn't tell them that you are using serverless. And then when they find out that they like them, then maybe you'll tell them, well, that's actually a serverless thing. And by the way, yes, I built that stream processing system on top of function as a service. So it is possible. And then that's it. Thank you.
Hi, good talk, thank you. I've been dabbling a little bit with serverless, and my main observation is that I'm used to use at least a local development environment and then debug code or functions no matter how easy they are. But what I run into either is I need to code into the Lambda editor in Lambda or in AWS, or I need to upload and package every time I make a change, which is kind of the hell for anyone who wants to fail fast and try out new parts and new ways of doing things. So that's part one. How do you recommend how doing that one? And the second part is it doesn't really fit with any kind of Git flow structure because everything is uploaded as zips and not even integrated with AWS own Git serving service.
Okay, so I'm going to start with the second one because I think it's easier.
Thank you.
Okay, so for the second one, there are ways that you can integrate. In our pipeline, we have integrated that, so we can make deploys kind of easy. We use Circle CI, but I'm pretty sure it can be done on anything. So we create a deployment role and only give that role permissions to update the Lambda function. And then we have a bash script there that does that. And then when we pass a tag, let's say deploy, then it will just package and send it, basically. But there are ways to integrate with AWS, though, by code pipeline and other things. But I don't particularly like those tools, but it's possible. I've done it myself. And on the first question, I think it's more difficult. So I tried to, if you are using a lot of AWS services, it gets really hard to test locally. But I tried to tell people in my team that I should be able to, if they're making an API, I should be able to run it locally as a Flask application, for example, where I can hit the endpoints and I can call the main logic of my app. But if you have if you are integrating with a lot of AWS services, it gets really difficult. There is the SAM product, but I don't really like it. I think I try to separate the logic very clearly from the events that gets triggered and try to take a look at Terraform plan. Because for the Lambda functions, I try to keep the triggers within serverless, for example, the framework, but all the other gluing on Terraform. So I'm not sure if this answers your question. I think it's very vague, but grab me for a conversation, because I think the answer is not easy anyway. Yeah, okay. Gracias. Thanks.
My question is about a specific application. So I'm concerned with applications where which have long warm starts, right? Like which have the warm start problem. So how do you circumvent, or do you have some tips or some hacks for like circumventing the warm start problem? And it gets tricky, especially when it's across multiple threads, I would say, like multiple, if you've got like Lambda with like running 50 cores, right? So how do you keep it always, how do you ensure that your code is always warm? Is there some hack or some approach?
Yeah, we run into that problem, but not as very often, since we don't use this for very APIs that are very heavily hit. We mostly use this for data processing, I believe, and for gluing at small tasks. But for the data processing pipeline that I mentioned, we run into that problem, and then we basically just make sure that the Lambda is running every now and then. So we create an event every now and then. So you can create something like a CloudWatch event that makes sure it's run every 5 minutes or 1 minute and keeps the container running so that it's not going to be down. I've not seen a better solution than that, but that's what we did for this.
That sounds like a very inelegant and brute solution. That's what we've been doing, but it sounds very
I know.
inelegant and brute. Is there some smart way of estimating that, all right, you need this much time to do it? Is there?
I've not really seriously thought about it, because as I told you, you are not using this for APIs. I guess if you are doing an API that is heavily hit, you should really think about it. But I went to reInvent last year, and I didn't see anybody doing something more clever than that. I'm not sure if between then and now, someone came with a very clever solution.
So, did you have any definitely test suite for doing that? Or any tool that can help you testing? Or definitely you didn't do any testing of the Lambda functions?
Oh, no. The testing should be as any other general project. But initially, what people feel tempted to is exactly to structure the project differently. But I think everything, like your main logic should not depend on the Lambda functions or the gluing code. So you should be able to test that as usual. And then for the Lambda functions themselves, like the triggers, I think there's a lot of discussion about it. Like how do you test that this should trigger that other thing? And that, I think that's something that people are still figuring out. Like how do you test your Terraform code, for example? I don't think somebody has an answer. It's just like, I guess because you're moving from environment A to environment B, for example, from development to staging, you make sure that because you are writing infrastructure as code, which are all of those triggers, then you would expect that if your system is running dummy data on staging and it's behaving well, you kind of expect it to be happening like that. The same is happening on production. That's how I see it, because I've been wondering and going into discussions with my team about this, like how do we test this infrastructure? How do we make sure we are not, by accidentally deleting a trigger and then breaking the system? And the answer is we would just write another Terraform for it, and then that doesn't make any sense so far. So that was pretty much the consensus, and we spent a lot of time thinking about this. So maybe it's something that we tried by deploying as often as we could, and by having an automated pipeline for things that move infrastructure, like automated pipeline for Terraform, for example, might help you move quicker.
Okay, so for just be clear, right now there is no way to do a full integration test of the whole pipeline.
I mean, you can try to run that AWS services locally, but in my opinion, that local setup is really tough, and there are stuff that you're gonna break. So I'd rather prefer to have a very good environment where I could just run Terraform, and it just comes up out of the blue, and I can test there that my triggers are working fine.
Thank you.
So first on the warming question, I think there is a nice solution, because I think we recently deployed on my company. I don't know the details because I just attended the tech talk. We recently deployed something that pre-warms like a really heavily heat API. But my question is, maybe in reInvent this year they presented a new Cloud 9 thing with Amazon, like Amazon bought Cloud 9, and then they want to like have you coding in this environment. Do you think that's tending towards fixing that issue that we cannot like test and actually like have a development environment that looks like our production environment in serverless?
Oh yeah, I mean that's meant to solve that, I guess, because then now you can click run there and you get the CloudWatch logs there. So it's like what you are used to in a regular development environment. I try to stay away from it, maybe because I love Emacs way too much. I think I'm biased by that little fact. But I mean, I have someone who uses a lot of these AWS services, and he's using it, and I think he's quite happy. But I tend to think all of my core logic should run locally, and I should be able to test it locally, and then most of the glue should be in Terraform, in my opinion. And so I don't know how being in Cloud 9 can help you test the gluing. I don't think it helps you with that. So it helps you like to just being able to run it faster. Like if you just want to test the run of the Lambda function itself. But I guess at the end of the day, there are two things you want to test. One is the glue, and the other one is the logic. And I make sure locally I test the logic as good as I can. As term of glue, I don't think Cloud 9 really helps you with that, in my opinion.